Good morning, everybody. I'm really honored to be here. I've learned a lot already from Mark's introduction about the recent breakthroughs in natural language processing. And maybe to make a good connection to the breakthrough, Swiss Text is a forward-looking conference. And next Monday, IBM is going to announce their next breakthrough in artificial intelligence, which is the IBM Debating Technologies project. So I don't know how many of you are familiar with that project. IBM started a large-scale research program about 5 years ago, whose main objective is to develop an automatic debater. So this is a follow-up research program to the Watson project, which has been successfully commercialized. And the first public presentation of the IBM Debater project is going to happen next Monday in the United States. So please be aware of that and watch the news. My talk is very much related to that because since several years there has been increasing interest in computational argumentation, in natural language processing, artificial intelligence, and beyond. And a good deal of the papers which Mark has mentioned in his introduction have been written in my lab about this particular topic where enormous progress is happening right now. And since I'm a representative of academia, my talk will be mainly focused on latest results in foundational research needed to enable automatic argumentation technology. So the work I'm presenting here is a result of several projects and a result of the efforts of multiple members of my lab. And before I start, I will introduce the topic by making a claim. People love to argue. So why is it so? So is this claim true? Any opinions in the audience? So why people love to argue?
It's a game so you can win.
People like to win something, like a game, very nice. So any other reasons why people love to argue?
People like to hear themselves talk.
Excellent. Thank you. Another reason?
People like to be different than the others, so they will try to expose another point of view, which is more...
To express their personality, exactly. Right. Wonderful. Thank you very much. So as you can see, we already have several reasons. Whenever I have such a almost philosophical question, I look on Quora. And actually, there have been many questions like this, interesting enough, and there are many reasons given for that. So the reasons I like are the following. When people are engaged in debate, they are effectively joined together in a search for truth. So we want to figure out something, and debating with somebody helps us. Another reason is that for thousands of years, in many unrelated cultures and traditions, many serious thinkers have held that the best way to get closer to the truth again, insight or reality, is through types of argument. Next, it is a primary learning method in yeshivas, that is religious schools. Even modern science is a sort of the long multi-partner, multi-strand argument over time, right? Research is about argumentation. We propose something and we argue for that and we try to convince the other this is the right way to go. And finally, arguing is an extremely effective way to gain knowledge, learn about another person, understand yourself, as a colleague has already mentioned, and just practice communicating. We just like to talk to each other as human beings, and also it is exciting. So I hope that by the end of my talk, you will all be convinced this is true. So maybe to connect this topic to something that I'm sure the most of you already know, sentiment analysis, let us think how these two problems are related. Sentiment analysis has been studied for many years already and has found its way in many successful products, and it's mainly about analyzing opinions of people about a specific topic, that is about a specific target. So how is argumentation different from that? When we argue, it's not only about expressing our opinion, that is expressing our stance, but we want to convince somebody to change their opinion and to think in a specific way. That's the main difference. And the definition which is often used to define argumentation is as follows. Argumentation is the verbal, social, and rational activity aimed at convincing a reasonable critique of the acceptability of a standpoint, so there's a specific standpoint that is a claim, by putting forward a constellation of one or more propositions to justify that standpoint. That is the reasons or the premises. And I have to say that, in fact, at least up to my knowledge, there has not been yet a large-scale study of how sentiment is exactly related to argumentation, because argumentation has many facets and it's very often not rational. So you will be surprised when you study argumentation empirically that only a small proportion of arguments are rational. Argumentation is also a lot about rhetorics, about emotions. So actually the bridge between sentiment and argumentation is something that yet has to be studied at large scale. So now let us introduce some basic terminology. An argument is a claim supported by reasons intended to persuade. So this is a short summary of the introduction I have given. And in real data, it looks like this. We have a claim: physical education should be mandatory in schools. And we have a reason, also called premise. More than 100,000 people died in 2011 due to lack of physical activity and obesity. And then there's a specific relation. For example, in this case, the premise supports the claim in order to prove that the claim is correct. In real data, we account much more complex argument structures. And instead of support relations, we can also have attack relations. And here is a more complex example taken from a persuasive essay written by a person: living and staying overseas is an irreplaceable experience when it comes to learn standing on your own feet. And then there's a premise: the one will learn living without depending on anyone else. And which relation is it, support or attack? Whispering, support. More confident, that's correct, thank you. And then there's another one who is living overseas will of course struggle with loneliness. And obviously this is the attack relation. And then things get more complex because there's another premise. Those difficulties will turn into valuable experience in the following steps of the life, which again attacks the previous one. And all in all, it changes the overall stance of that text snippet to a support relation at the end of the day. So the main task of automatic argument analysis is extracting these kinds of structures, claims and premises, and the relations between them from naturally occurring language data. Computational argumentation is actually a huge field. So it's not only studied in natural language processing and artificial intelligence, it's an interdisciplinary topic. So there are hundreds of years research in philosophy. So the work by Aristotle, which was quite fundamental, psychology, social sciences of different kinds related to argumentation, and there exist several hundred of argumentation theories. So that topic is pretty multifaceted faceted, I would say. There are different ways how one could look at it. And in terms of natural language processing, the first and the very fundamental thing is that we want to find arguments and their structures in real life text. But also another thing related to hate speech, by the way, the hackathon is about the hate speech, is assessing qualitative properties of argumentation. For example, identifying fallacies, such as personal attacks, could be helpful. And well, producing good arguments is really, a high inference skill we need to train for many years in school, universities, and so on. So quality of argumentation is a topic in itself. Then we want to explain things, so we want to find reasoning chains in the data. That requires integration of domain and world knowledge very often, because a lot of argumentation is actually implicit. We presuppose that our partner knows certain things, so it's not mentioned on the surface, which makes natural language processing and understanding very hard. And finally, argumentation, as I have mentioned, is a social act, basically. So in many cases, it's not only facts and rational reasoning, but there's a lot of social context involved. And all these topics are being studied in the current NLP research agenda. The focus of my talk today will be primarily to introduce some research results from the first area, finding and analyzing arguments in naturally occurring text. So in our lab, we also have work related to all other areas I have mentioned, but unfortunately, it's impossible to put everything in one talk. If you are interested in those aspects, please come and talk to me. I will be here today and tomorrow. My talk will have two parts, and the first part will be about large-scale argument search, classification, and reasoning, while the second part will focus on a problem which I think is very fundamental for this technology to find its way to real-life application, that is creating real, high-quality annotating data. So it's very laborious, and we need a lot of research in order to reduce efforts for producing annotated data. So in the first part, I will talk about our project aimed at developing an argument-based search engine called Argumentext. And the second part will be about document-level stance classification, which you might be more familiar with through the term fake news detection, because this task is very related to fake news detection. So let us start with cross-topic argument mining. The main goals in this project are the following. We want to find arguments in a large corpus of text. So we use a huge corpus called Common Crawl, crawled from the web, given a specific topic, for example, autonomous driving, which is a controversial thing, in arbitrary sources. So we go from unstructured text, extract arguments, and then we classify them according to their stance for or against that topic. And also one particular thing is that the arguments we find in the data should not only express a stance, because this is what opinion mining does, or sentiment analysis. It should also contain the reason why it is so. And the challenges that we have in this research project are the following. Previously, argumentation has been studied in relation to one particular discourse type. For example, there's a corpus of persuasive essays, and people work on that. But argumentation is quite varied in different discourse types. So we want to be able to have an annotation scheme and a model which can capture argument in heterogeneous texts, heterogeneous with respect to their types, genres, and writing styles. Also, we want to be able to produce a large amount of annotated data in short time, and we want to generalize our argument extraction model to different topics as we find those in the web search scenario. The requirements for the annotation scheme, and we need to develop one because there has been no previous work on this topic, so we need to define the problem and produce a data set, are the following. It needs to be general for various text types, as I've already mentioned, and it has to be simple enough so it can be applied by untrained annotators, because annotating argumentation is very costly, so it takes a lot of time, it takes a lot of training, but we cannot afford it. Nowadays that we use deep learning techniques, we need lightweight annotation methods to produce large-scale data sets. And the annotation scheme that we have proposed here defines an argument to be a span of text expressing evidence, supporting or opposing the given topic. And each sentence is classified according to 3 labels: supporting argument, attacking argument, or no argument at all. Here is an example. We have a topic, nuclear energy, which is our search topic, and from the data we extract sentences. Nuclear fission is the process that is used, blah, 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 so it's just like an explanation sentence, and it contains no argument, so it will be annotated as no argument. And then the second sentence, it has been determined that the amount of greenhouse gases have decreased by almost half because of the prevalence in the utilization of nuclear power, is an argument in support of our text topic, so it will be annotated as the supporting argument. A common way how to get to a large-scale data set nowadays is crowdsourcing, and this is what we propose to use here for annotation. And it requires many considerations how we can make this annotation accessible to non-expert annotators on a crowdsourcing platform. So we collect our data from the web using the Google Search API, and then we perform annotation experiments with the help of crowdsourcing using the Amazon Mechanical Turk platform, and we can successfully show that this way we can collect high-quality annotations with a high level of agreement among annotators, and we can scale this process to different domains. In particular, we annotate 40 topics in less than a week, which is an excellent result, utilizing a workforce of 750 workers on the web. And the resulting corpus has a very substantial size of 25,000 instances of high-quality annotations. And in an empirical study, we find that the level of agreement, statistical inter-annotator agreement between annotators on the crowdsourcing platform is as good as the level of agreement between experts annotating the same data sets, and you can see this in the graph for 8 different topics. Now, after we have produced the data set, we develop computational models that can classify each sentence in terms of our classification scheme. We have 3 labels, pro-argument, con-argument, and no-argument. And the first experiment that we do in a cross-topic way, that is, we train on all topics except the test topic. So we can test the generalizability of the model, is aimed at integrating contextual information in a neural network. So LSTM is a common approach nowadays for such experiments, and in our experiments we use a new approach which integrates the topical information directly into this model. So it gives access to more knowledge about the topic, because the arguments are supposed to be semantically related to the topic. In our second experiment, we test the idea of using multitask learning, which is becoming more and more popular in research in order to improve our classification result. And here we combine the model we have previously developed with the contextual information with a model which is learned on an external data set. So there's an external data set where each topic is annotated with sentences relevant to that topic. So the main idea here is that we utilize the knowledge from a different data set unrelated to our project in order to improve the classification results for the argument extraction model. And the graph summarizes the results of these experiments. I will briefly explain. So the models that we proposed here are the blue one and the orange one. And we have two experimental setups. One of them, two-label setup, classifies each sentence as argument, non-argument. This is a simpler task. Then three labels setup where we have additionally the stance classification. That is pro-argument, con-argument, and no-argument. And we have three baselines shown in all other colors. And we can see also we have the human upper bound determined by means of inter-annotated agreement. This is the last column. So the first thing we can see is that our models can outperform the baselines or the best baseline, which is the bi-LSTM model, by about 5% of F measure, which is a very substantial agreement. So the multitask learning helps, and also the contextual LSTM model helps in this case. But we can also see that there's still a huge gap between the best model and the human upper bound. So this is a task which still requires much more research in order to be fully solved. And obviously, of course, the results for the three-label setup are worse than for the two-label setup because stance classification is also still a hard research problem. So the main takeaways from this project at its current stage are the following. We believe that this technology has huge potential, especially for practical applications in customer feedback analysis, online journalism, or educational applications, because all of those and many more require extraction of arguments from naturally occurring text. And an interesting thing is that this argument search engine is already available as a prototype, so you can take note of this address and experiment with it a bit. And for the research findings, we have introduced a new annotation scheme which is applicable to arbitrary web texts and scalable to different topics. We have proposed a new approach how to collect high-quality training data by means of crowdsourcing. And finally, we have proposed two novel models which can improve the results of state-of-the-art methods. First, by integrating topic-related information with the common deep learning approaches, and second, by leveraging information of data sets from similar tasks to further improve the classification performance. So now I move to the second part of my talk, and this is about the document-level stance classification for fake news detection. So you will recognize many things. There are some similarities to the first project, but this one has a different focus. In particular, this project has been started on the basis of the fake news challenge. The fake news challenge has been introduced last year. It was a virtual competition, and a big number of teams, I think over 50 teams all over the world, participated in that competition. There were also many companies, not only universities, and our team was one of the participants. And mainly this task is about the stance detection. That is, we want to determine the relative perspective of a text with respect to an entity or a claim. So the stance can be support or attack. You have already seen that in my examples. And it is a well-known component in abstract argumentation frameworks. And an example look like this. We are given a headline of an article: hundreds of Palestinians flee floods in Gaza as Israel opens dams. And then there are documents, right? So one major difference to the first project here, we work not on a sentence level, but on a document level. There's a long text, and this text may or may not be talking about the headline. And here in the case, southern Israel does not have any dams, said a statement from Koget. We need to determine the relation, and the relation is a disagree relation because it disagrees with a headline. So in other examples, like hundreds of Palestinians were evacuated after Israel opened the gates, blah, blah, blah. This can be an agree relation, so the document can agree with the headline. And there are two further labels. So here we have 4 labels, and the remaining 2 labels are the unrelated label, that is, the text does not talk about the headline at all, or the discuss label. The text talks about the headline, but does not express any stance, either in favor or against the headline. Okay, so there are 4 different labels. And you may ask, how is this related to fake news detection? So it's actually the first stance. In order to verify a claim, we need to collect all documents that disagree or agree with the topic, and then there will be a second step, which is not addressed in the fake news detection challenge, will be reasoning over this set of documents. So if we look at the results that we have got from the challenge, the results look pretty high. So we got second rank in the overall ranking with very minimal distance to rank 1. And the results look like 82%, great on the first side. But unfortunately, this is fake news. The results are not so good, because we found after this challenge that the evaluation metric is very problematic. It neglects the skewed data distribution. Obviously, you know, the frequently occurring class is unrelated, and if we use a simple heuristic, only getting unrelated, related correct, and then predicting always the majority class discussed among the 3 remaining labels, we already outperform the best system. So whenever you participate in such challenges, please keep your eyes open what they are doing. And because of this, we conduct a scientific study based on the results on the challenge to verify the results. So we reassess the top performing models with better metrics, and here we propose to use the macro F1 score, which can weight the results according to the frequency of labels in the data to avoid the skewed distribution effects. And also we annotate a subset of the data to see how much human agreement we get, because the human agreement typically gives us the upper bound for evaluations. And we find that while 4 classes give quite high agreement of 0.75, but there's a but. If we only look at 3 labels from the related classes, that is agree, disagree, and discuss, the agreement is quite low. So there's not much of agreement between humans on those classes. They are highly controversial. And remember, we deal with long documents. This is the reason why it's so hard, because sometimes the documents expresses reasons for and against, and it's quite mixed. And also we perform additional experiments with a new data set that we utilize for this task in order to see if the results of the top performing systems can transfer to other data sets. So the top scoring system of the challenge were the following. The Talos, it's a company system, uses deep CNN combined with gradient boosted decision trees. Then the second rank, our system, which uses an ensemble of 5 multi-layer perceptrons with 6 hidden layers and some handcrafted features. And the third rank is the UCL model, which is also a multi-layer perceptron with bag-of-words features. And we reassess those systems, and we get quite a different picture of results that you can see here. So in the table, we can see the models that I've been talking about, the majority vote, which is our baseline, and the human upper bound, which tells us how good the system could be on this task. And we have the overall results: agree, disagree, discuss, and unrelated. And it's important to also look at the results class-wise or label-wise, because the label distribution is very skewed, as I've already mentioned. And well, according to the new evaluation, it turns out that our system is in the first position with a F measure of about 60. And the top-ranked system, Talos, is still the best one on the agree class, but it does not perform so good on the discuss class. So the results change after we apply the evaluation metric. And also in this task, as the previous one I have discussed in the context of cross-topic argument search, you can see there is still a big gap between the current model's performance and the human upper bound. There's still a lot to do in this task. The main reasons for that are the following. The top performing systems are mostly based on lexical overlap between the headline and the text. And it takes into account words like reports, said, false, hoax, and those have a huge impact on the classification. But the current models still fail when they need to take semantic relations like synonymy, hyponymy, entailment, and this type of knowledge into account. So this is what the models cannot capture very well. And also, very often disagreement is a huge problem, but this class is extremely important. So generally, the systems are quite bad on the disagreement class, because disagreement, especially in use stories, is often expressed in complex terms. So actually, it takes a huge effort for a human to understand that the article disagrees with something and understand the reasons behind that, because it's a bit hidden, like a diplomatic language. If the bizarre story about blah, 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 and actually you need to pay attention to the language used in order to recognize the disagreement behind that. So now, in summary of this part of the talk, I've talked about sentence level argument identification and stance classification. And I've introduced a new data set by means of crowdsourcing, 2 new models. And I've made the conclusion that there's a huge gap to human performance yet. And for the second task, the document level stance classification, we reassessed the results of 3 top performing systems. We introduced a second data set, which I have not described in the talk, but you can find the details in the corresponding papers. And the main open issues based on our error analysis is dealing with negation and the required inference that the current models do not capture. Now, in conclusion of my talk, I would like to introduce the last part of experiments on how to reduce the annotation effort required to produce this kind of the data sets. And the paper I'm going to talk about is the paper on the cross-lingual argumentation mining with the title Machine Translation and a Bit of Projection is All You Need. So the main question that we address here is how to extract argumentation in languages other than English. So producing annotated data is hard. So for English, we already have some data sets, though not enough data to study many tasks. And for other languages, we don't have almost any data. So this is a big problem in this context. And we perform some experiments on the data that exists in other languages. In particular, we have a small corpus of bilingual short texts in English and German. We have the monolingual Chinese review corpus annotated for major claims, claims, and premises. And we have the monolingual persuasive essays from our previous work in English, which we translate by human annotators to the German language and also to German, French, Spanish, and Chinese by means of machine translation. So now the question is how to come from the English corpus to the German corpus. We have an English sentence: since it killed many marine lives, tourism has threatened nature, and then we want to be able, by using the English annotated data, to analyze a German sentence, which is a translation of that one. So we adapt two popular approaches in the area of cross-lingual NLP. The first is a direct transfer. This approach operates on source language with gold labels and directly applies a model which is trained on the shared representations, so-called bilingual word embeddings, to the target language. And the second approach we experiment with is the projection approach. This approach operates on the target labels while on the target language with noisy labels. So the labels are automatically projected to the target language. And here we adopt the projection algorithms to handle spans rather than individual tokens proposed in part of speech tagging and named entity recognition. And one of the models for argument mining is that we need to develop models that can capture long-range dependencies. So it's not classifying locally individual tokens, but the arguments can span quite a long distance in the sentence. Our main findings are the followers. On the microtext data set, we get very good results for the cross-lingual transfer because these texts are simple and the translations can be aligned very well, so the transfer works well because components of arguments mainly depend on the punctuation. The results of translating or transferring from the Chinese hotel reviews to the English data are very bad. Actually, they are worse than our random baseline, and the reason for that is actually not the language projection, but the reason is the domain difference. So the systems fail due to the domain shift from the hotel reviews to persuasive essays, which are about different domains. And for the persuasive essay data set, you remember there is a human translated version of the English corpus in the German language, and then there are 4 machine translated versions of the same corpus. We find that the projection approach works considerably better than direct transfer. So it's better to project the labels to the target language and train a model on that language in order to receive classification results which are comparable to the in-language performance. So in summary, for persuasive data set in parallel versions, we find that both approaches, direct transfer and annotation projection, make errors at the beginning of the components due to auto-vocabulary problem and due to misalignments. And the direct transfer makes a lot more errors, and we find almost no difference on the projection based on human translated and machine translated results. So when we have no domain gap between the two corpora in two different languages, we find that all we need is very cheap machine translation, which is readily available, and the naive projection of labels to the target language. So the conclusions of my talk are the following. Computational argumentation has great impact on a large number of downstream tasks, and the methods that we currently have work sort of okay in a single domain and cross-language, but cross-domain remains still a big challenge. A feasible approach is to simplify tasks to small ones, which we can solve hopefully easier, though the real inference and reasoning, and they are very important for argumentation, are still very hard. In our future research, we are going to look at the ways how to integrate more domain and background knowledge as well as common sense reasoning into the neural networks models. We are going to pay more attention to the pragmatic and social dimensions of argumentation, and there is still a huge number of open research problems, which is why I want to invite all you to join this exciting research field. Thank you very much for your attention.
Thank you, Iryna, for this great talk. I would have a couple of questions, but I think maybe the audience has also one or two questions, but quick ones because we want to save time. Any questions?
I just have a question and observation. So in the work you're doing, you assume that from one language to another you have one sentence expressing one idea, yeah? And you rely on that. What do you do in situations where one sentence from one language is translated into two sentences or three in another? Is that possible to overcome that?
That's a good point. Our current model does not take that into account. I mean, how often this happens is an open question, so I don't know. And actually, I often receive a similar question. What happens if one sentence expresses two different arguments? One is pro and the other is against. For that, we have done an empirical study, and it's less than 1%. So currently, we ignore this situation, but the model could be extended to handle that if that phenomena turns out to be important. Thanks.
So combining the language translation and the argument search, what we could do is having multiple languages, translate to one core language, and then do the argument search on top of it. This would work.
So I did not quite understand the scenario. So you have multiple languages, you translate to one core language, perform the analysis on that, and what do you do then? Then project to the original.
No, and just get the arguments across all the languages.
Yeah, so this is something that could be done, yeah.
Okay, let me move here. So, I would like to thank you, Iryna. Now this is a famous ZHW wine. We have also some Rebwerk, a wine distillery, and this is red wine. I hope you enjoyed it.
Yeah,
really
wonderful.
Great.
Thank you very much.
Thank you
yeah,
very
I
much,
enjoyed it
Iryna.
a lot. Thanks.
Thanks again.